we've made it away into vectors, and one thing that we're going to do a lot of is vector addition. So here is a video about vector addition examples. I'm going to start with a couple of different vectors. Here we go, 3 vectors, A, B, and C. What I would like to do is come up with a couple of combinations. I'm going to say, let's find vector D, which is going to be A plus C. So I need to break vectors A, B, and C into components. Vector A, I will do that one first. So here is an X component and a Y component. AX is going to be equal to A times the cosine of 37. A is 5, 5 times the cosine of 37 is 4, and I'm looking at meters per second. AY, I'm going to do the same thing, but I'm doing this one with the sine of the angle. So I'm going to have an A times the sine of 37 degrees, and that's going to give me 3 meters per second. B is just fine. C, I'm going to have to break that one into components. So I have a CY that points down, a CX that points over. CX is going to be C times the sine of 5 because that is the opposite angle. So I'm going to get 5 times the sine of 30 degrees. That's going to give me 2.5 meters per second. CY, I'm going to get a C times the cosine of phi here. And so I need to plug those numbers in, and I get 4.3 meters per second. So I have all the pieces I need. I'm looking for A plus C, so I'm going to make my table A, C, and I'm going to say vector D is A plus C. Here's my X and Y, and there is my table. Over here I will put a double line to remind myself that this is where I am doing my math. So vector A has an X component of 4 meters per second, has a Y component of 3 meters per second. Vector C has an X component of 2.5 meters per second. It has a Y component of 4.3 meters per second. But it points downward, so a negative. My vector D is just A plus C, so I'm going to add these up. 4 plus 2.5, that gives me my 6.5 meters per second. 3 minus 4.3 is a negative 1.3 meters per second. Vector D is going to be 6.5 meters per second. In the X direction, negative 1.3 meters per second. In the Y direction, let's go ahead and assume that we have to come up with the reconstructed vector. Dx is 6.5 meters per second. Dy is 1.3 meters per second. It's negative, but that just tells me it points downward. So coming up with my diagonal, I'm going to say d is going to be the square root of dx squared plus dy squared. And that gives me 6.6. I guess 6.63 if you like, meters per second. I'm going to need an angle, so let me label this angle here. I know that my angle is going to be the inverse tangent of dy over dx. I put that in and I get 11.3 degrees. So if I have to list this in the other form, I'm going to say this is 6.63 meters per second at 11.3 degrees. I was facing east, I turned to the south, so south of east. Either of those answers is correct, depending on which form I am asked to find. I'm going to do another one. Maybe vector E. Let's make E a complicated one. We'll go 2c minus b plus a. That should really do pretty much everything that we can get it to do. So I'm going to write these vectors in. Vector c, vector b, vector a. And then I will put my x and my y. X, y, and then I'm going to put my ending definition. E is 2c minus b plus a. It's a lot. But it's a lot on purpose. Here we go, I'll fill these in now. So vector C is 2.5 meters to the right, meters per second, and it is 4.3 meters per second downward. Vector B is just 4 meters per second downward, and vector A is 4 meters per second to the right, 3 meters per second up. What I have is 2c, so if this is going to be 2c, I need to multiply this by 2. That gives me 2 times 2.5 is 5. And I need to multiply this by 2. 2 times negative 4.3 is negative 8.6. I've got minus b, so a negative b gives me negative 0, that's just 0, and a positive 4. And then plus a as is, so that's good. 5 plus 0 plus 4, that's 9. Negative 8.6 plus 4 is negative 4.6, plus 3 is negative 1.6. So my vector E looks like 9 meters per second. In x, negative 1.6 meters per second. In y. If I have to reconstruct this thing, I'm going to get 9 meters per second in x. X is 9. 1.6 in y, it's in the negative direction, which is what that minus sign is all about. And so I get my resultant vector this way, E. I know E is going to be the square root of EX squared plus EY squared, which comes out to be 9.14. And if I throw an angle here, I know my angle will be the inverse tangent of EY over EX, comes out to be 10.1 degrees. So I can also write this vector as 9.14 meters per second at 10.1 degrees. I am facing east, turning south, so that is south of east. Two ways of doing these problems. This was a fairly complicated vector addition, definitely about as complicated as these get. So once I break this into components, I can throw this into my table. Once I've got my table, it really is just manipulating and adding the columns as much as I need to, then reconstructing in the end if it's required. That's it.